Hello, welcome to a new video. Today we're going to do 131 palindrome partitioning. It's a medium problem LeetCode. This problem is really hard for me, even though it's a medium problem. I think backtracking is my worst part of questions. But I'm getting used to it. I've watched like 3 videos multiple times, and it's been like I think 2 hours of me just thinking about this problem and like trying to understand it, but I think I do understand it a little bit. Um, First off, I didn't know what partitioning was until now. Well, I keep forgetting what it is and I keep relearning what it is, but I think this time, like, since I struggled really hard, like I do understand what a partition is. But yeah. At first I was looking at this like, okay, why is there multiple sublists? Why can't we just add all the substring? Why can't we just add all the palindromes in one resulting list? But then that only makes sense to know the question, like to know the answer of why, is to understand what a partition is. So yeah, so let's get started. Um, yeah, I'm gonna try to hopefully regurgitate what I've learned. So start off with reading the problem. So given a string S, given a string S, partition S such that every substring of the partition is a palindrome. Return all palindromes partitionings of S. So we're basically given S, string S, then our output is going to be a 2D list, 2D list, sublist equal to type of that hold strings, and then there's supposed to be partition palindromes of partitions. Um, yeah, to be honest, it doesn't make really much sense to me. But looking at it and learning about it and like seeing how people deal with it, like it just makes sense. But I think the wording for me doesn't make sense. Every substring of the partition is a palindrome. So stuff, I don't know, it's weird. Partition slash stuff, it's kind of confusing to me. But I feel like if this was an actual interview, I would like go really in depth with an interviewer. So like, what do you mean by like partitions? Like, what do you mean by partition and that every substring of that partition is a palindrome? Like, there's like a jumble of words, but hopefully I will explain to you what that means clearly if you're watching this video, if you're wanting to learn or just watching. Let's do an example, right? So I'm just going to copy this example, AAB. So let's say this is it. Well, let's see. So to get the output of this, I should actually note what a partition is, just to make just to make it make sense. So to note so what is a partition? Well, partition is basically a part. Basically a part. Um, it's basically a part. So basically, from this AAB, right, we can take it apart, but only twice. But only twice for each part. Basically, take away a single part if when take away there will be only one, there will only be when taken away it will be cut in half. The left half is the partition, right is the leftover, right? So there's only 3 partitions of this. So with AAB, there's only 3 partitions. So there is a partition where we get A and cut off the AB, and then there is a partition where we cut off between A, B, So it would look like this. So yeah. Then there's a partition where we just include the whole thing. It's just AAB, right? And then so from this, what they want us to do is they want us to go through each partition, and then once we go through each partition to see if they're um, if they are palindromes, they want us to go deeper. And so check the leftovers of this partition. So in this case, the leftover of this partition is AB, and then they want us to keep on continuing slicing through it to see if there is a um, a palindrome within each, right? And so in this case, so this is leftover, right? This is the leftover, right? And then so for this one with A is our first partition. So we see that A is a palindrome. So since A is a palindrome, let's go over to the leftovers of that partition, which is just AB. And then what we want to do is we want to slice, we want to partition AB, right? And so to partition AB, we just slice it, say, okay, A, and then B, right? That's basically it. And then, so from the first partition, we can see that A is a palindrome of itself, AB can't be a palindrome, and so now we slice, I mean, it doesn't really matter if this is a palindrome or not, but because we just want to slice through AB, we just want to keep on continuously slicing. And so then we see, once we slice AB, we see that A is a palindrome of itself and B is a palindrome of itself. So what happens is that we will get a resulting list of A, B, where we get the first A in the list is from this A, and then the second A from this list is when we slice this AB, and then we find that this A is a palindrome, and then the B is from the slice of the leftover, right? And so yeah, that's pretty interesting. And then so that's one of the sublists in the resulting list that we're going to send out. And then now, once we're done with the first partition, which is just A, and we sliced its leftover into its own partition, we're gonna go to our second partition, which is AA, right? And then, so we see that AA is a palindrome. So what we're going to do is we're going to go through its leftover. So the leftover is just B. Leftover is just B. And then from there, what we see, excuse me. So from there, what we see is that, yeah, the leftover is a palindrome too, but we can't really go more in depth in it because, yeah, because we're to reach the end of the string. So this resulting list is going to look like this, right? Where AA is a palindrome, so we add it in there, and then B, the leftover, is a palindrome, so we're just going to add it into the sublist as well. And then from here, we kind of already AAB is not a palindrome, so we can't add it in, and we can't go further, because it's not a palindrome, and because even if we just go over, there's nothing left to go on. So yeah, that's pretty much it as like an example. It's a good example because it showcases all the cases, I guess, that could be possible. I was looking at this, it's so frustrating, it makes me so frustrated. Like, I'm just thinking about the code of it. I don't really like it as much, but whatever. Okay, so, um, let's go back, right? So we did our example. We know what a partition is, and if you don't know what a palindrome is, I should have explained it further. What is a palindrome? So a palindrome is basically same word. Same word. So if word is reversed, it is the same. So like, what's a good example? So I guess the acronym like LOL, if you reverse that, reverse is equal to LOL also. So yeah. And then yeah, also with dad, reverse is equal to dad. So yeah, those are what palindrome is and a partition is. You need to know both in order to solve this problem. So let's go into the matching phase before we code, kind of showcase what to do, or how to implement it. So we're gonna solve this with recursion. I'll also do like a for loop to iterate through to partition, for loop for partitioning. Um, and then what else? We're also gonna do to check if a palindrome, so reverse string with just this. It's like Pythonic. But what we could also do is we could also just do like a while loop, left, left and right. And then we just keep comparing left and right. Yeah, that's pretty much it. So let's go ahead into some coding. Um, First off, make a resulting list. And then what we can do is make that first search function. And what I want this to do is I want to take in the index and the current, the current string that we're going through. And no, in the current partition, oops. So current palindromes, let's say palindromes, right? And so first off, um, okay, so first off, what I want to do is, so if it is a palindrome, then we want to append it, right? So, so in the case or in such, in order to return the list of palindromes, we're going to say so if the index is more than equal to the length of the string, then we're going to return return palindromes. Right? No, we're not going to return palindromes. We're going to add it into the resulting list. So add palindromes. Right? So that makes sense. Um, and as we can see here, we did this as an example. Right? So once we reach the end, basically, we get this list, and then we can't go any further because we already hit B, right? So we can't really go any further, so we just stop. Yeah. Um, and then if that's not the case, um, then we're just going to do our basic stuff. So we need to iterate through, we need to get all of the partitions. So get all the partitions. So, so it's gonna be kind of strange because we're going to start from, so for I in range, so for starting, well, for index in range, I'm just gonna say for I in range, and then um, the I is gonna start at the index, right? And then we're gonna go up to the length of s, which is the string. I say for I in range, starting at the index because in here, right? Um, so just say we started our first partition, which is A, and we notice that A is a palindrome. So, so the rest of, so the rest of the palin, so the rest of, so the rest of this, right? So the leftover is A and B. And what we do in A and B is we literally just go through, really just go through, we literally partition that. So with AB, what we do is that we say, okay, so we partition AB. Then go with A, then B. We don't go through the whole thing yet. So that's why I say that. So basically, I is going to I is going to help us partition in a sense, and index is going to say where we're going to start with the partition, right? I know it's kind of confusing to me, but that's just how it is. Maybe I'm not understanding this correctly, but that's how the code that's how the code looked to me. And then we need to check if partition is check if partition is palindrome. So we say if so if yeah, if palindrome so if palindrome okay starting from if s starting at index plus one no plus I plus one to because slicing is exclusive, so we say I plus one to make it inclusive. Um, is palindrome. Then we're going to go through that first search. We're gonna go through that first search again, saying that I is gonna start at I is gonna start at I plus one, right? And then we're gonna give it cur, right? Because if it is a palindrome, we're going to add palindrome to cur, right? Or to palindromes. And then and then once we add it, backtracking, we always have to pop it. So pop palindrome. Okay, so yeah, that's how the code should work. So when we find out that it is a palindrome, we say I plus one, because we're kind of excluding the I. We're saying that, okay, so just start at the leftovers. So go through the whole string at the leftovers, right? And then, yeah, that makes total sense actually. So if we find that this is a palindrome, we're gonna say, okay, so if that's a palindrome, then go through I plus one. No, then start at I plus one, which is just the leftovers. So I can say, so check if partition is palindrome. If palindrome, go through leftovers starting at I plus one. So check if palindrome, then if palindrome. So if palindrome go through leftovers starting at I plus one, and then this whole thing just keeps on looping, right? So once we go through our first recursion, we say, okay, so I gotta take a sip. So once we go through our first recursion, we start at A, B, right? Or technically we start at A. And then A is gonna be like, okay, I am a palindrome, so I'm gonna go through B, which is my leftover. It's because I'm a partition. And then B is like, okay, I'm a palindrome, so I'm gonna add myself into here. And then what's gonna happen is that A, B, no, is that we're gonna return to A. And then you know how we did I plus one, right? So we did I plus one. So I'm gonna say this is I equals to one. And oops, no, index is equal to one and I is equal to one. All right, so this is index one, I equal to one, right? What about where index is equal to one and I is equal to two, right? Because that's what's gonna happen in this for loop, right? When we get it back, we're gonna pop out that we're gonna pop out, and then we're going to go back into here where we go through for I in range. Index is still 1. I is now incremented to 2. And then we're going to go here where this is index is equal to 1 and I is equal to 2. So it's going to check if this whole thing is is um is a palindrome or not, and it's not. And so basically when this A says it's a palindrome, what's going to do, it's going to say that the index is now I plus 1. So this index is 2, and then I is equal to 2, and so on. And then that's how we're going to see like what's going to happen, right? So yeah, it's really the code, it makes sense, but the way it's coded out and how the code runs compared to how you go over it through your brain or through my brain, 'cause my brain's special. It's just really strange because it's like they go through the same thing, but your brain knows that okay, if we know that A is a palindrome, then we go through leftover. But the code says if we know that A is a palindrome, then we're going to go through the first letter of the leftover, right? So I guess the way that I should say is if palindrome go through first letter, go through first letter of leftover. Cycle repeats. Get all partitions like A, A, B of A, B. So yeah, I don't know, it's kind of weird. Yeah, I don't understand it, but I'm just getting a little bit more understanding of it. But hopefully, when I go through all this, it just makes sense. So if I basically, um, oh, I didn't submit it. Okay. So basically, so if we just copy this, so res is equal to this, and then the def ifs is gonna take in index and then a cur. We'll say cur temp res. And then we have to check the base case where the index it's more than equal to the length. I'm gonna say that instead of length, I'm gonna say because I'm gonna be referencing the length of s. So n is equal to the length of s. So if index is more than equal to n, then we're going to append a copy of the temp res. Temp res is gonna hold palindromes. So say temp res holds palindrome of partitions, palindromes of partitions. And then for I in range, starting at index all the way up to n. So we're gonna get all the partitions. So we're gonna go through all partitions of the string, starting at the index. So then we're going to check if the partition is a palindrome. So I'm gonna say so. Um, so, so say substring. So substring is going to equal to starting from s at the index all the way up to I plus 1. So if substring is equal to substring reversed, right? Then we're going to basically append that substring into the temp res. So temp res dot append substring, and then we're going to say Okay, so if you are a palindrome, then we're going to go through your leftover starting at the first index of that leftover. So call DFS with I plus 1 because that's the starting index of the leftover. Um, give it temp res. Then once we head back, so basically, once we solved this partition, we don't want to make this hold everything in here. We're gonna say that once we're done with the first partition, we're gonna make this empty. So at each time, we're gonna just pop. So we're gonna say temp res that pop. So we start anew. And then yeah, that should solve the whole problem for us. That's the whole algorithm. And then to kind of start solving this, like actually we have to call BFS with index 0 and an empty temp res, and then return res because once we call this, it should populate res, and so we're going to return res and then run it. And it works. Oh my god, so much thinking. My brain is completely fried. Like, I don't know. I don't know, man. So for time complexity, I'm pretty sure it's 2 to the n, 2 to the power of n. Um, for space, I don't know. I can't think right now. Like, I'm burnt out already. Like, damn, I spent like 2 hours and 30 minutes, or maybe 3 hours, trying to understand this problem. And I don't really understand this problem, but I'm getting it a little bit. So yeah. Ay, ay, ay.